Good day everyone. Today I'm going to explain about a question that I solved by using completely randomized design, which is well known as CRT. My name is PERAMALAY, my metric card number E21A0748. Now let's look at the question. So the question is the distance required to stop a vehicle on wet pavement was measured to compare the stopping power of 4 major tire bands. Each brand of tire was tested on the same vehicle on a controlled wet pavement. The stopping distance were shown in the following table. So on the table we have 4 brands and then each brand have 5 distance, A and B. So let's look at A. A is identify the treatment, response variable and the type of experimental design used. B is there sufficient evidence to conclude that there is a difference in a mean stopping distance using alpha 0.05. Let's look at the question A. So for question A, we should identify a treatment, response variable and the type of experimental design used. So for the treatment, which is 4 different brands of tire A, B, C and D, response variable, the stopping distance of the vehicle on wet pavement, experimental design, as I previously said, completely randomized design, CRD. For question B, we should first of all create a NOVA table. So now I have provided the table of given in the question. On bottom, a NOVA table. On right side, the answer of SS total, SS treatment and SS error. So for ANOVA table, you should firstly have to complete the sum of square. So how to calculate the sum of square, treatment, error and total? So for sum of square, treatment, error and total. So let's look at on the right side. So for sum of square, treatment, error and total. So let's look at the right side. So SS total, how to calculate SS total? So when you calculate the SS total, you have to use all the numbers that are provided in the table. So for SS total, you should take 37 until the number of the end 41. So each number you should put in bracket and square root to plus. So lastly, there are 768, which is what are the number? The number is the total number of distance and also divided by 20. So the 20 is we have 4 brand, 5 distance. So 4 and 5, which is 20. So the total distance, the total number on the table is 20. So when we calculate, we will get SS total is 196.8. So same as goes to SS treatment. But for SS treatment, we should add at 1 over n. So what is 1 over n? 1 over 5. So 5 we have 5 distance. So n is represent 5. So we should calculate. But this time we should not going to use the 37, 38, 34 the numbers on the table. But also we using the table number. But for treatment we going to use the number, the total number of each brand. Which means total. The 5 distance should be added and the equal of which is the brand A 185. Brand B 194. Brand C 182. Brand D 207. So each put in bracket plus square root. So minus by 768 divided by 20, we will get 75.6. So we already get the SS total and treatment. Now for finding the error, it's really easy because SS total minus SS treatment, which is 196.8 minus 75.6 equals to 121.2. So now we completed the sum of square. So now to get the degree of freedom, it's easy because I already given the formula on the table. A minus 1, which is A is 4, we have 4 brand. So minus 1, 3. Now we jump to the total, which is total number of this, total number. So which is 20, we have 20, right? And then minus 190. So now error, it's quite easy because 19 minus 3 equals to 16. So already we find out the number of sum of square and degree of freedom. So now to identify the mean of square treatment, mean of square error, which is you should divide sum of square treatment divided by degree of freedom treatment, which is 75.6 divided by 3 equals to 25.2. And same goes to mean square of error, which is 121.2 divided by 16, we will get 7.6. So F value we will get, how we will get? By mean of square treatment divided by mean of square error, which is 25.2 divided by 7.6, we will get 3.32. So did we answer the question? No, we should answer it more, which is the last part. H null equals to mu1 equals to mu2 equals to mu3 equals to mu4. H1 equals to mu1 not equal to mu j for at least one pair. Alpha 0.05 test statistic, which is the F value that we calculate, which is 3.32, and critical value F0.05, the 3 and 16. The 3 and 16 where we get, which is the degree of freedom of treatment and error. So now we should see on the statistic table alpha 0.05 of the value of 3 into 6, which is 3.24. So now we already identified the value of 0.05 in 3 into 16, which is 3.24. So the decision is reject H null is have calculated bigger than half table. So which is have calculated is 3.32 bigger than F table, which is 3.24. So in conclusion, mu I not equal to mu j for at least one pair. So we solved question B.
Next RCBD, I asked the AI ChatGPT to give me the question about the RCBD with the citation. So the question is, a researcher is investigating the impact of 4 different irrigation techniques on the growth of wheat. To control for variation in field condition, the researcher organized the experiment using RCBD with seed blocks based on the land topography. From the question, we can find the output, which is treatment for irrigation technique 1, 2, 3, and 4. Experimental unit with factor, the irrigation technique applied, the dependent variable, the growth of wheat, replication of lot 6. His effect model that I'm going to use is Yij equal mu plus tau I plus beta j plus epsilon ij. This table shows the output with block total, treatment total, and average. The output is same like AI ChatGPT give, but I make a table that easier for me to understand. For find the SST, I use this formula, and the answer for SST is 27.76. But AI ChatGPT use another formula. Next, I'm gonna use this formula to find the SS treatment, and the answer is 12.236. But AI ChatGPT use another formula. Next, SS block, I use this formula to find SS blocks, and the answer is 14.735. But AI ChatGPT use another formula. To find the SSE, I use this formula, and the answer is 0.789. For SES, the formula AI ChatGPT use is same like me. Next, we're gonna make a ANOVA table. Just for column degree of freedom, the answer is same. For other columns, it may be different because of the different calculation way above. The hypothesis for AI ChatGPT is accept, but for my hypothesis is reject because I've calculated 77.528 greater than F table 3.29. Because of I reject the H null, so I have to do 30 tests. H null equal to mu I equal to mu j. H1 equal to mu I unequal mu j for all I unequal j. This number I got from the average. And here. After that, we reject H null if absolute y bar y bar I minus y bar j absolute greater than T alpha. The conclusion is mu T1 unequal mu T2, mu T1 unequal mu T3, mu T1 equal to mu T4, mu T2 unequal mu T3, mu T2 unequal mu T4, mu T3 unequal mu T4. Why just mu T1 equal to mu T4? Because of mu T1 equal to mu T4 got 0.083 less than T table 0.34131.
Last but not least, two-factor factorial design. I chose SET at all 2024. study about the effect of planting media composition and concentration of vegetable waste, liquid organic fertilizer on the ground of oil palm seedling. The effect model used to factor is Yijk equal to nu plus tie I plus beta j plus tie beta ij plus eijk, which I refer to the factor A, j refer to the factor B, and k refer to the replicate sample. On this study, we want to see the effect of planting media composition on crown fresh weed and root fresh weed. So here have a two factor. First factor is growing media and observation parameter. For this study, experiment unit is growth of oil palm seedlings. Factor is effect of planting media composition on crown fresh weed and root fresh weed. Treatment is media composition. First is topsoil plus cocopeat, second topsoil plus hard charcoal, and third topsoil plus cocopeat and plus hard charcoal. And the replication of the study is 4 replicate and the randomization is 24. So there is a results that have a provide on this case study. Right, so for this case study, we have a two hypotheses, which is a hypothesis null is there is no interaction between growing media and observation parameter, and the hypothesis 1 is there is an interaction between growing media and observation parameter. For answer for accept or reject the hypothesis, we need to make an ANOVA table, and for make the ANOVA table, we need to calculate the sums of total sum of growing media, sum square of observation parameter, sum square of interaction, and sum square of error. For the sum square of total, we use the formula and we get 2525.02. For the sum square of growing media, we use this formula and we get 150.14. For the sum square of observation parameter, we use this formula and we get 2050.54. And for the sum square interaction, we use the formula and get 16.64. And for the sum square of error, we get 342.69. And after we have done switch, calculate the sum square each type, so we can make a ANOVA table. So this is an ANOVA table. For get the degree of freedom, A minus 1 for the growing media. For the observation parameter, B minus 1. And for the interaction between growing media and observation parameter is A minus 1 multiple B minus 1. And for the error is A multiple B multiple N minus 1. For the total, A multiple B multiple N minus 1. To get the mean square of growing media per A minus 1, mean square of observation parameter per B minus 1, mean square for the interaction, mean square of growing media multiple mean square of observation parameter per A minus 1 multiple B minus 1. And for the mean square error per A multiple B multiple N minus 1. After we get the mean square, so we can calculate the F null, which is mean square of growing media and observation parameter per mean square of error, so we get 0.44. Back to the hypothesis null, there is no interaction between growing media and observation parameter, and null 1, there is no interaction between growing media and observation parameter. Using the alpha 0.05, the test statistic equal to the F interaction equal to F null equal to 0.44. For the critical value, F alpha A minus 1 multiple B minus A and A multiple B multiple N minus 1 with the F alpha 0.05 with the degree of freedom that we get is 2 and 18. And if we see that at the F table, we get the 3.55. So, in this case study, decision that we do is sin F calculated is 0.44 less than F table, 3.55. So we accept hash all. There, this conclude there is no interaction between growing media and observation parameter.